Kirchhoffs voltage law, otherwise known as Kirchhoffs loop rule, otherwise known as loop analysis, basically says that whenever you have a circuit, the total amount of voltage or potential difference that you have around a loop is equal to zero. So let me just give you an example of what this means. Let's just say we have a circuit with a power supply. Let's just say we have two resistors. So here's resistor 1, here's resistor 2. Let me just label this. This is going to be V. I'll call this R1. I'll call this R2. What it's saying is that the potential difference, the voltage that's being used by every element in the circuit is, or in the loop I should say, is equal to 0. So in this case, what it means is that V plus whatever the V is across this resistor plus whatever the voltage is across this resistor, so V plus V1 plus V2 equals 0. That's Kirchhoffs voltage law. And actually Kirchhoffs voltage law really is just an application of the law of conservation of energy, because we know that voltage is potential difference, which is related very much to energy, because basically potential, electrical potential that we're looking at, is our joules per coulomb. And so when we're looking at joules per coulomb here, we're looking at joules per coulomb here, we're looking at joules per coulomb here, we're saying that basically the amount of potential in one complete circle is equal to 0. And it makes sense if you think of it in terms of potential energy. Because if you think about it, let's just say we have, here's the floor. If you were to take a ball, if you lift it up into the air, you're giving the ball some potential energy. But then if you let the ball go back down to the ground, it's going to lose that potential energy. And so the difference in the potential from the starting point to the ending point is 0. It started out with 0 and ends with 0. And so we don't really have any change in potential. Well, the same thing's happening with the electrons. They're starting basically at a spot. Let's just say they're starting right here at the bottom of the battery, bottom of the power supply. As this charge is going around, it's going to end up right back where it started. And so since it ended up right back where it started, the potential difference is 0. There is no change in the potential from the beginning to the end. And so that's why if you add up all of the different potentials of the elements in the circuit, they're going to add up to 0. So it's really important to understand that we're looking at these loops, and that's what's also called Kirchhoffs loop rule, is that with every single loop in the circuit, when you add up the potential differences in that entire loop, it's going to equal 0. That's really the whole principle. And I want you to understand it really is just conservation of energy. A lot of the stuff we do in circuits relates back to conservation laws. So conservation of energy, conservation of charge. It's important to understand how these all tie in with each other.